The boron reading on Kirkland Signature is the number that reframes the comparison. Warren Distribution built the Kirkland 5W30 formula around borated succinimide dispersants at high concentration, giving it a strong boron reserve that persists through a standard drain interval and keeps combustion byproducts suspended and in solution for the filter to capture. Mobil 1 Extended Performance comes in with a more moderate boron load and a heavier organic molybdenum friction modifier package instead. These are not two oils competing at the same formulation strategy. Warren chose deposit control and dispersancy as the primary protection mechanism at the price point Kirkland operates in. Mobil 1 Extended Performance chose friction reduction and extended drain reserve. Kirkland Signature is manufactured by Warren Distribution, one of the largest private label lubricant producers in North America. The Kirkland formula is built on a Group 3 full synthetic base stock, the same base stock classification used by Pennzoil Platinum and Quaker State Ultimate Protection, Group 3. Base oil is a highly refined petroleum product, produced through hydrocracking and hydroisomerization of crude oil fractions to remove impurities and reshape molecular structure. Modern Group 3 hydrocracked base stocks do not shear down under mechanical stress on their own. The base oil molecule is stable. What shears is the viscosity index improver polymer. Viscosity index improver polymers are long-chain molecules added to a finished oil to give it multi-grade behavior. Without them, a base oil that flows correctly at 100 degrees Celsius would be far too thick at cold temperatures to circulate on startup. Viscosity index improvers allow a thin base oil to behave like a thicker one at operating temperature by expanding as temperature rises. Under sustained mechanical shear, those polymer chains fracture, and once a viscosity index improver chain breaks, it does not reform. The oil's effective viscosity drops permanently toward the underlying base oil's natural kinematic value. Kirkland Signature shears toward the lower boundary of the 30-weight window after a standard drain interval, and that movement is a function of the viscosity index improver formulation, not a weakness in Group 3 base stock chemistry. An oil built on the same Group 3 base with a more robust polymer package would hold grade longer. The viscosity retention story is about polymer quality, not base stock classification. Mobil 1 Extended Performance is built on a polyalpha olefin and alkylated naphthalene base stock blend. Polyalpha olefin is Group 4 synthetic, uniform molecular chains engineered for shear resistance. Alkylated naphthalene is Group 5, added to improve oxidation stability and solve polyalpha olefin's natural solvency limitation across extended drain intervals. The polyalpha olefin base stock contributes its own natural viscosity stability in the operating temperature range, which reduces the demand placed on the viscosity index improver polymer to hold grade across a long drain. That base stock architecture is part of why Mobil 1 Extended Performance carries an advertised drain interval of up to 20,000 miles. Kirkland Signature comes back at 9.2 to 9.6 centistokes at 100 degrees Celsius after a standard drain. Mobil 1 Extended Performance comes back at 9.6 to 10.1 centistokes. Both are 5W30 oils. The gap is real and traceable to polymer shear behavior over the drain interval. Fuel dilution tolerance is where the base stock architecture difference creates a practical gap. Mobil 1 Extended Performance carries a high fuel dilution tolerance rating. Kirkland Signature carries a moderate rating. In turbocharged direct injection engines, raw fuel washes into the crankcase on cold starts before combustion temperatures stabilize, thinning the oil by diluting the base stock. The polyalpha olefin and alkylated naphthalene blend resists viscosity loss from fuel contamination better because the synthetic molecular structure has lower polar interaction with fuel compounds than a Group 3 chain under the same dilution load. At a standard 5,000-mile drain on a vehicle that sees normal mixed driving, neither oil reaches a problematic viscosity floor. Extend Kirkland's drain interval into territory the formulation was not built to support, and that tolerance difference becomes a real operating variable. The total base number is the clearest separation in this report. Mobil 1 Extended Performance enters fresh at approximately 8.5 milligrams of potassium hydroxide per gram. Kirkland Signature enters fresh at 7.2 to 7.6 milligrams of potassium hydroxide per gram. After a standard 7,500-mile drain, Mobil 1 Extended Performance retains 2.8 to 3.6 milligrams of potassium hydroxide per gram remaining. Kirkland retains 1.8 to 2.4. At 7,500 miles, both oils still carry acid-neutralizing chemistry. At 10,000 miles, Mobil 1 Extended Performance holds meaningful reserve. Kirkland does not. The initial total base number deficit combined with a faster depletion rate makes the drain interval decision the most consequential choice a Kirkland owner makes. Wear metals at standard drain intervals are where the value argument for Kirkland lives, and the numbers are honest about it. Iron comes back at 7 to 12 parts per million in Mobil 1 Extended Performance, and 8 to 14 parts per million in Kirkland. Copper runs at 2 to 4 in Mobil 1 Extended Performance, and 2 to 5 in Kirkland. Aluminum and chromium are identical across both reports. The gap exists and is measurable. At a standard 5,000-mile drain, it is not large enough to dismiss the Kirkland result. Warren Distribution's formula produces wear metal readings that track within a narrow range of a premium extended drain product within the interval it was designed for. Mobil 1 Extended Performance carries the higher organic molybdenum friction modifier load, running a heavier concentration at the boundary lubrication zones, where cam lobes and ring contact faces operate under high load. Kirkland's borated succinimide dispersant strategy compensates at those same zones through a different mechanism. Boron keeps the surfaces cleaner, reducing the abrasive wear load from accumulated combustion deposits cycling back through the contact area. Both strategies protect the engine. They address different failure modes, and the wear metal data at standard intervals reflects that both approaches are working. Calcium comes back at 1,000 to 1,200 parts per million, remaining in Mobil 1 Extended Performance and 1,100 to 1,300 parts per million. In Kirkland, a slight Kirkland edge on total calcium. Magnesium runs at 650 to 800 in Mobil 1 Extended Performance and 500 to 700 in Kirkland. A Mobil 1 edge that reflects a stronger low-speed pre-ignition suppression commitment in the magnesium-calcium detergent split. Zinc dialkylthiophosphate readings land close. Mobil 1 Extended Performance holds 750 to 850 parts per million zinc and 650 to 750 phosphorus. Kirkland holds 700 to 800 zinc and 600 to 700 phosphorus. A modest Mobil 1 Extended Performance edge on anti-wear chemistry that does not change the outcome at standard intervals. The verdict depends on the drain interval. At 5,000 miles, Kirkland Signature Full Synthetic delivers wear protection that tracks within a narrow range of Mobil 1 Extended Performance at a fraction of the price per quart. Warren Distribution's high boron dispersant strategy keeps engine internals clean across a standard interval, and the wear metal data confirms it. Mobil 1 Extended Performance earns its price premium only when you are running the extended drain intervals the polyalpha olefin and alkylated naphthalene base stock was built to support. A 7,000-mile drain on Mobil 1 Extended Performance is well within its engineering envelope. The same 7,000-mile drain on Kirkland is operating past the total base number reserve the formula was designed to carry.